Okay guys, we can use molar mass to convert from grams to moles or from moles to grams. So yes, we can use it as a conversion factor. So let's look at some problems where we do that. Alright, in the first problem it says calculate the number of moles of water in 50 grams of water, H2O. Alright, so the first thing we want to do, and I often tell students this, the first thing you want to do in problems like this is calculate the molar mass. Since we're converting between grams and moles or moles and grams, just go ahead and calculate the molar mass of your substance because you'll be using that to convert from one to the other. So here I have, for example, 2 hydrogens, and so I'm going to say 2 times, rather than saying 1 AMU, I'm just going to go straight to grams, right, because I'm calculating molar mass. Then I have 1 oxygen, so that's going to be 2 times 16 grams. And so I have 2 grams, and I have 16 grams. Then I'm simply going to add these up, and that's going to give me 18 grams, which is going to equal to 1 mole. Okay, so 18 grams of water is equal to 1 mole of water. Alright, and so I can use this as a conversion factor. So let's check out how this sets up. Alright, I'm looking for number of moles, right? So I'll say number of moles of H2O is simply going to equal to what I'm given, 50.0 grams of H2O. I'm going to draw me a cross here. Now, I need to get rid of grams and thus get in moles, so I need to use this conversion factor. 1 mole of H2O, right, divided by 18 grams of H2O. So that grams of H2O cancels and I'm left with moles of H2O. And so when I carry this calculation out, I get 2.78 moles of H2O. And that's my answer. Okay? So let's look at the next problem. It says calculate the number of grams and 2.55 moles of sodium chloride, NaCl. So first thing I want to do is calculate the molar mass of sodium chloride. So I have 1 sodium. Each sodium is going to have a molar mass of 23 grams. And then chloride, 1 chloride will have a molar mass of 35.5 grams. I get these numbers from the atomic mass units. Okay, but rather than using AMUs, I'm using grams because I'm calculating molar mass now. Alright, and so I'm going to sum these up. I just add them up, so this will be 58.5 grams. Alright, so I'm looking for the number of grams here, right? And they give me 2.55 moles, so I say, okay, number of grams of NaCl is simply going to equal to 2.55 moles of NaCl. And I need to get rid of moles of NaCl, so I'll put 1 mole of NaCl on the bottom here. Right? Remember, 58.5 grams of NaCl is going to equal to 1 mole of NaCl. Alright? And so I can use this as a conversion factor. And so I'm looking for grams, so I'm going to put 58.5 grams of NaCl up top. So the moles cancel and I'm left with grams of NaCl, and so that's going to equal to 149 grams of NaCl. So that's my answer there. All right, so I'll label this problem as 1 and I'll label this problem as 2. So in problem 1, we were going from grams, number of grams of the substance, to number of moles of the substance. And so whenever I do that, I'm going to simply calculate my molar mass of the substance and just say, okay, 1 mole of that substance divided by the grams of that substance from the molar mass. Okay, all right, or as I say, 1 over molar mass. Okay, which will be just the molar mass flip, so it'll be 1 mole of the substance per number of grams calculated for the molar mass of that substance. And then in 2, we were going from number of moles of the substance to number of grams of the substance. And so whenever I do that, I need to multiply by the molar mass. All right, so I multiply by the molar mass, which is expressed in grams per mole. All right, so that's how we carry out calculations using molar mass to convert from grams to moles or from moles to grams of a substance, guys. Practice, practice, practice. That's going to help you out tremendously. Okay, students, let's look at this problem. A tablet of aspirin, C9H8O4, contains 0.360 grams of aspirin. How many molecules of aspirin are present? All right, so what we want to do first is calculate the molar mass of this aspirin. All right, so we have 9 carbons, so we say 9 times. You could use AMUs here, 12 AMUs, or we could just say 12 grams because we're calculating molar mass, which is going to be expressed in grams anyway. So there's nothing wrong with that. All right, so we have 8 hydrogens, so we say 8 times 1 gram, because 1 hydrogen is 1 AMU. So 1 mole of hydrogen would be 1 gram. Okay. And we have 4 oxygens. So that's 4 times 16 grams. All right. So 12 grams times 9. That's going to give me 108 grams. Then I have 8 times 1 gram, that gives me 8 grams. And then I have 4 times 16, so that gives me 64 grams. And then I'm going to sum this up, and that gives me 180 grams. And so that is going to equal to 1 mole of aspirin, C9H8O4. So 180 grams of aspirin is going to equal to 1 mole of aspirin. Okay, so now remember, if I have 1 mole of a substance, then that's going to give me 6.022 times 10 to the 23rd, in this case, aspirin molecules is going to equal to 180 grams or 1 mole of aspirin. So I can use the 180 grams and the 6.022 times 10 to the 23rd aspirin molecules as a conversion factor, right? All right, so if we want to calculate the number of aspirin molecules, I'll put molecules down here. All right, so what I will do here is molecules. I'll start with what I'm given here, this 0.360 grams of aspirin. All right, I'll just put the formula for the aspirin. How about that? All right, and so I need a conversion factor that will allow me to cancel the grams and thus be left with number of aspirin molecules. And so since I'm looking for the number or how many molecules of aspirin are present in 0.360 grams of aspirin, I will write the 6.022 times 10 to the 23rd C9H8O4 molecules up top, and that will allow me to find the number of aspirin molecules, and I want to get rid of grams, so I write the 180 grams of C9H8O4 on the bottom, so that grams cancels with grams, and when I carry this calculation out, I get 1.20 times 10 to the 21 C9H8O4 molecules. So this is how many molecules are present in 0.360 grams of aspirin. Okay, so in this next problem, they want us to calculate how many moles of oxygen are in 0.350 grams of aspirin. All right, guys, look at this chemical formula. This formula conveys a lot of information to us. One thing it says is that for 1 mole of aspirin, C9H8O4, I'm going to have 4 moles of oxygen atoms. See the 4 right here? That's where I get it from the formula. So for 1 mole of C9H8O4, I'm going to have 4 moles of oxygen, right? So I know that the molar mass for aspirin I calculated in the previous problem to be 180 grams per 1 mole. All right, so I can use that as a conversion factor. So if I have, let me see here. So for 180 grams, that is equal to 1 mole of aspirin. All right, so I can take this equality and use it as a conversion factor. So how am I going to do that? Well, I'm going to say the number of moles. We're also going to use this as a conversion factor. So I'm going to say the number of moles of oxygen is simply equal to 0. What I'm given in the problem is 0.350 grams of aspirin. So I'll write that here. And again, you want to practice. It's good practice to make sure you write the substance along with the units that correspond to it. Just good bookkeeping there. Alright, so how do I get rid of grams here? Well, if I put 180 grams, so I'm going to utilize this as a conversion factor. If I put 180 grams of C9H8O4 in the bottom, that will allow the grams to cancel with the grams up top. And ultimately I need to get it in moles of oxygen, so I'll put my 1 mole of C9H8O4 up top here. And now I'm going to use this as a conversion factor. So I've used this as a conversion factor here. So now I'm going to use 1 mole of C9H8O4 is equal to 4 moles of oxygen. So I put 4 moles of oxygen up top because that's what I want to calculate here. And I'll put 1 mole of C9H8O4 on the bottom, so that moles of C9H8O4 cancels. And so when I carry this calculation out, I get 0.0078 moles. Yeah. All right. So this is just a taste of how we carry out moles to gram calculations or grams to mole calculations, or in this case of this problem here, how we can go from grams to number of molecules using Avogadro's number in this case. So when we're looking for a number of something, we need to consider using Avogadro's number. A number of atoms or a number of molecules or a number of ions, use Avogadro's number. Okay? So I hope this video was helpful, and I will try to get some more videos up as soon as possible. Thank you for your patience in viewing of these videos.